So let's look at a problem that could actually happen in real life. So Mr. B is selling hamburgers and hot dogs. He wants to sell at least 10 units. That means 10 or more units. He charges $5 for a hamburger and $2 for a hot dog. He wants to make at least $30. That's $30 or more. He only has 5 hamburger buns, so he can sell at most 5 hamburgers. So let's take a look at some questions based on this scenario. Could he sell 5 hamburgers and 4 hot dogs? Well, since Mr. B's goal was to sell at least 10 units, and 5 plus 4 is only 9, this does not work. So he could not sell 5 hamburgers and 4 hot dogs. Could he sell 7 hamburgers and 4 hot dogs? Well, 7 plus 4 is 11, and that is at least 10 units. He wants to make at least $30. So 7 hamburgers at $5 each would be $35. That's already more than $30, so that works. However, it says here that he only has 5 hamburger buns, so he can sell at most 5 hamburgers. So is Mr. B able to sell 7 hamburgers? No, he is not. So this could not happen because he cannot sell 7 hamburgers. So even though this satisfied 2 of our restrictions, because it didn't satisfy that third restriction, it doesn't satisfy our problem. Could he sell 1 hamburger and 40 hot dogs? Is this at least 10 units? Absolutely, 41 is bigger than 10. Will this make him at least $30? Well, he'll get $5 for the 1 hamburger he sells, $2 for every hot dog, so that's $85. That's definitely more than 30. Is he selling at most, which means less than or equal to 5 hamburgers? Yeah, he's only selling 1. So could he sell 1 hamburger and 40 hot dogs? Absolutely. Could he sell 3 hamburgers and 7 hot dogs? Well, this is at least 10 units. 3 plus 7 is 10. Is he going to make at least $30? Well, 3 times the $5 is 15, and 7 times 2 is 14. 15 plus 14 is 29. So this won't make him enough money. So we're going to write a system of statements modeling the relationships between the amount of hamburgers and the amount of hot dogs. So based on our scenario, we know we need a system. It means 2 or more rules, or more. Sometimes we have more than 2 rules. So Mr. B is selling hamburgers, which we're going to use as X, and hot dogs, Y. He wants to sell at least 10 units. So we have 10, and then we have units is X plus Y. So whatever hamburgers he sells plus however many hot dogs needs to be at least 10. At least is greater than or equal to. So X plus Y is greater than or equal to 10. He charges $5 for a hamburger, $2 for a hot dog, and he wants to make at least $30. So we know we need to make at least $30. We charge $5 for a hamburger, so 5x, $2 for a hot dog, so plus 2, and we want to make at least $30, which means that 5x plus 2y has to be more than or equal to, so greater than or equal to $30. And our final restriction is that he only has 5 hamburger buns, so he can sell at most 5 hamburgers. So we have 5 hamburgers. X represents hamburgers from up at the top here. So we have X, and X has to be at most or less than or equal to 5. So this is our system of inequalities. So we have 2 or more. This time we had 3 rules, and the rules that we have our x plus y is greater than or equal to 10, 5x plus 2y is greater than or equal to 30, and x is less than or equal to 5. So what we're talking about here is how do we write systems of linear inequalities? So this is our system of linear inequalities. It has two or more inequalities. So let's look at another example. Farmer Indid wanted to sell some quarts and bundens at the market. She could sell at most 14 units. She planned to charge $3 per quart and $8 per bunden. She expected to make at most $72. She had to sell at least 2 bundens. Write a system of statements modeling the relationships between amount of quarts x and the amount of bundens, which is going to be y. So we need a system. That means 2 or more. So first we have that she can sell at most 14 units. So we'll start with the 14. The at most tells us that whatever we sell, which goes on our left side, has to be less than or equal to 14. We can't go over 14. And our units means she's just going to sell quarts and bundens. Those are the only two things that she's selling. So we have x plus y is less than or equal to 14. Then we expect her to make at most $72. So we'll start with our 72. We make at most $72. So we can't make any more than $72. Therefore, we must be making less than or equal to $72. We're going to charge $3 per quart and $8 per bunden. So this is 3x plus 8y is less than or equal to 72. She had to sell at least 2 bundens. So we know we have 2. At least means greater than or equal to. And bundens is our y variable. So we have y is greater than or equal to 2. Choose the true statement. She could sell 6 quarts and 0 bundens. So let's see. All we need to do is substitute our quart numbers in for x and the bunden numbers in for y. So 6 plus 0, that's less than 14. 3 times 6 is 18, plus 0, that's less than 72, but then we get to y is greater than or equal to 2. 0 is not greater than or equal to 2, so it cannot be our first choice. What about 18 and 3? So if we have 18 and 3, 18 plus 3, notice that 18 plus 3 is 21, and that is not less than or equal to 14, so that doesn't work either. What about the 12 quarts and 3 bundens? So 12 plus 3 is 15. That's not less than or equal to 14, so we can eliminate that. What about 19 and 3? Well, 19 plus 3 is 22. That is also not less than or equal to 14, so that is also not true. So none of these statements are true statements. Let's look at another example. Farmer Vreel wanted to sell some shubles and looks at the market. She needed to sell at least 11 units. She planned to charge $7 per shubel and $4 per look. She expected to make at most $56. She had to sell at least 10 looks. Write the system of statements modeling the relationship between the amount of shubels, our x variable, and amount of looks. which is our y variable. So our system means we're going to have 2 or more statements. She needed to sell at least 11 units. So we'll start with our 11. We need to sell at least, that means greater than or equal to. And our units means we're just going to add x plus y. She expected to make at most $56, so we'll start with our 56. At most means less than or equal to. We can't go over 56. And then we need to add in our money expression. So that's going to be $7 per Schubel, or 7x, plus $4 per Luke, which is 4y. And then finally, she had to sell at least 10 Lukes. So we have 10, we have to be greater than or equal to 10, and this is our y variable. So here is our system of equations. So we can cross out any points that do not meet all the requirements. So 10, 0. 10 plus 0 is 10. That is not greater than or equal to 11. So we can cross that out. 0 plus 10, also not greater than or equal to 11. 10 plus 10, well, that's greater than or equal to 11. But then when we get to our second equation and we take 7 times 10, we get 70, plus 4 times 10, which is 40. So 70 plus 40 is 110. That is not less than or equal to 56. 12 plus 15 is greater than or equal to 11. But again, we have this same problem when we get to the second expression, or second inequality, where this is going to be too large also. 1, 12. So 1 plus 12 is 13, which is greater than or equal to 11. 7 times 1 is 7. 4 times 12 is 48. And 7 plus 48 is 55, which is less than or equal to 56. So we're still good here. And our y value is 12. 12 is greater than or equal to 10. So this one does work. 112 does meet all 3 requirements.